Lean Burn System Analyzer offers the service technician a fast, easy-to-use, accurate, and foolproof method for testing the entire Spark Advance system, the complete spark control computer circuitry, the coil and primary circuit, the distributor pickups and circuits, coolant and carb switches, the throttle transducer, and the vacuum transducer. In our June 1976 session, you saw how to troubleshoot the Lean Burn system by using the point-to-point system for diagnosing failure to start, poor performance, poor fuel economy, and high idle speed. Now you can do all this and more faster and easier with the electronic Spark Advance System Analyzer. In spite of all the complex tests performed by the analyzer, it is remarkably easy to use. First, all diagnostic tests are made without the engine running, since the analyzer automatically simulates all the driving conditions required for the tests. Second, the analyzer does all the testing, and you only have to make the physical moves it can't make itself. Let's quickly identify all the analyzer features first, then we'll go through a real on-the-car analysis. There's a power switch, and start, continue, and stop switches, which you'll be instructed to operate at specified times. You'll program the analyzer with the select test code knobs to match the computer you have on the car. When the SCC OK indicator light comes on, that's the end of the test, and you know that the spark control computer is OK. The TIC control light is not used. The carb coolant switch indicator light will tell you if these two important switches are operating correctly. Engine timing will appear in the timing window, and engine RPM divided by 10 in the next window. When a fault occurs, the fault light will go on, and the fault code number will appear. That's your signal to make a correction according to the fault code list. When the instruction light goes on, an instruction code will appear. That's your cue to perform some physical operation that the analyzer can't do itself. Make sure the ignition switch is in the off position. To hook up, remove the two connectors from the computer and insert them into the analyzer connector. Then insert the analyzer connectors into the computer. Connect the analyzer red alligator clip to the coil positive terminal. Do not connect the analyzer coil tower wire to the ignition coil. You will be instructed when to do this later. Connect the analyzer black lead to a good engine ground, such as the alternator ground terminal. Attach the magnetic timing probe clip to the engine timing indicator plate and insert the probe into the clip until it fully bottoms out on the vibration damper. Plug the power line into an AC outlet with a grounded third wire. Turn on the power switch and check the computer test code. Set the select test code switches to the code stamped on the computer. Next, check the carb coolant switch lamp on the analyzer. It should be on. You'll remember that the coolant temperature switch closes when the engine is cold and grounds out the computer vacuum transducer circuit through terminal 11. Terminal 11 is also grounded out when the carb switch closes, in the closed throttle position. For earlier cars with an idle stop solenoid, remember to turn the ignition key on to activate the solenoid. You can remember it this way. When the analyzer light is on, the circuit from terminal 11 is grounded someplace, either at the coolant temperature sensor or at the carb switch. Since it's easy to open the ground at the carb switch, if the light stays on, that means the ground is at the coolant temperature sensor, which is correct for a cold engine. Since the engine warm test must also be performed, we'll check the RPM, timing, and make the engine warm test all at the same time. First, press the start switch. Instruction code 1 will appear, which directs you to do either the RPM timing check or the diagnostic test. You begin the RPM and timing test by starting the engine and pressing the continue switch. However, if you have an engine that won't start, turn off the ignition and go right to the diagnostic test. Notice the additional spark advance caused by the start timer advance schedule. This will back off to basic timing in about 90 seconds. Run the engine up to operating temperature and kick off the fast idle. You can now finish the test of the carb coolant switches with the engine warm. The indicator light should be on, since the throttle is closed and the carb switch is grounded. Now, open the throttle and watch the indicator light. It should go off as you open the carb switch, since the coolant temperature switch circuit should now be open with a warm engine. When the idle RPM and timing are to specifications, you're ready for the complete diagnostic check of the rest of the system. Turn off the engine and start the diagnostic mode sequence by pressing stop, start, and then the continue switch. The analyzer will show instruction code 2. You will verify that the ignition switch is off. Then be sure to replace the coil center wire with the grounding wire from the analyzer. Again, press the continue switch. Instruction code 3 will appear, telling you to turn the ignition key to the run position. Code 99 will appear and flash briefly in the code window. Incidentally, code 99 will appear at various times and indicates that a test is in progress. This is your signal to wait for further instructions. When code 4 appears, you are instructed to crank the engine until a code change is seen, but for no longer than 5 seconds. When code 5 appears, release the ignition switch from the start position and allow it to return to the run position. When code 6 appears, you'll pull the hose from the computer vacuum transducer and connect a hand-operated vacuum pump. But be sure not to pump any vacuum until you're instructed to do so. Check to see that the throttle is off the fast idle cam. And press the continue switch. You should see code 99 flashing, indicating a test in progress. This will continue for about 90 seconds. During this time, the analyzer will simulate many different operating conditions and check the performance of the spark control computer under those conditions. You can watch the simulated engine speed changes on the analyzer. When the analyzer finishes code 6, it might go either to instruction code 7 or 8. Let's see why. Code 8 is actually a special code which appears only if the throttle position transducer is out of adjustment. When you adjust it, be certain the throttle is closed and off the fast idle cam, and adjust the transducer as near 0 as possible. The connector may be disconnected and reconnected as you make the adjustment without disturbing the test sequence. After the code 8 adjustment, you do not have to go back to step 1. Just press the continue switch, and if the adjustment is correct, you will now get code 7. Your instructions for code 7 are to hold the throttle wide open as you press the continue switch. You should now get code 10, since code 9 is not used. For code 10, release the throttle, allowing it to close completely, making certain the fast idle cam is not holding the throttle open. Then press the continue switch. When code 11 appears, pump in at least 18 inches of vacuum. Then press the continue switch. When code 12 appears, pull the vacuum pump release valve and press the continue switch. When the SCC OK lamp lights, you're through and you know you have a good spark control computer. And that all components in the primary ignition circuit are functioning properly. The coil, the starter relay, both sides of the ballast resistor, the ignition switch, carburetor switch, coolant temperature switch, complete distributor circuit, throttle position transducer, and vacuum transducer. Turn off the analyzer and ignition before disconnecting any of the leads. That leaves only the high voltage circuit in question, and that is easily checked by cranking and looking for a spark. When you first turn the analyzer on, you may get fault code 20. That means the analyzer code switches are set to an invalid test code. Check the computer code enter it on the analyzer, press the stop switch, then the start switch. Code 1 should appear. Also notice that code 1 will time out if no action is taken within 1 minute. To restart, just press stop, then start again. But here's a point to remember. Whenever a fault is found and corrected, you must stop and restart the diagnostic sequence from the beginning at code 1. Fault code 28 could indicate a fault in the analyzer, or it could be caused simply by a faulty connection of the red clip to the coil positive terminal. Fault code 35 says coil resistance out of tolerance. Again, it may be a question of connections or wiring. If these check out okay, replace the coil and start over from code 1. All other lean burn system faults are pinpointed just as easily, and there are corrections given. Once you've used the analyzer a few times, you'll be able to check lean burn systems in as little as 4 minutes. The analyzer is not only a service department time saver and money maker, but it also adds a lot to your confidence when you can say,
the lean burn system checks out 100%.